Ever looked up at the night sky and wondered what's really out there? Beyond the stars we can see. Well, surrounding our planet is something completely invisible, yet incredibly powerful. Two giant belts of charged particles, trapped by Earth's magnetic field. These are the Van Allen radiation belts, and they're one of the most significant discoveries of the space age. Today, we're going on a journey to explore these mysterious regions, how we found them, and why they're a huge deal for every single space mission. Our story begins in 1958, right at the dawn of the space race. The United States had just launched its very first satellite, Explorer 1. On board was a simple instrument designed by Dr. James Van Allen, a physicist from the University of Iowa. Its job was to measure cosmic rays, the high-energy particles that zip through space. As Explorer 1 orbited Earth, the instrument started sending back some really weird data. At low altitudes, it detected the expected level of radiation. But as the satellite climbed higher, the radiation count suddenly shot up so high that the instrument just stopped. It was completely overwhelmed. Then, as the satellite came back down, the readings returned to normal. At first, the team thought the instrument was broken, but when Explorer 3 was launched a few months later, carrying the same equipment, it sent back the exact same bizarre readings. Dr. Van Allen and his team realized they hadn't found a glitch. They had stumbled upon something monumental. Earth wasn't just a rock floating in empty space. It was surrounded by intense zones of trapped radiation. This groundbreaking discovery, made with the very first American satellite, revealed the existence of what we now call the Van Allen belts. It was a shocking revelation that completely changed our understanding of the near-Earth environment. So, what exactly are these belts? Imagine Earth as a giant bar magnet. It has a magnetic field that extends far out into space, creating a protective bubble called the magnetosphere. As the sun continuously spews out a stream of charged particles, known as the solar wind, Earth's magnetic field traps. Some of these particles, they get caught, bouncing back and forth between the magnetic poles like tiny ping-pong balls, forming two distinct, donut-shaped regions of intense radiation. The inner belt is the more stable of the two. It sits roughly 1,000 to 6,000 kilometers above the Earth's surface. It's primarily made up of high-energy protons, which are leftovers from cosmic rays that have smashed into atoms in our upper atmosphere. These protons are incredibly energetic and can be very damaging. The outer belt is much larger and more dynamic. It extends from about 13,000 to 60,000 kilometers out and is mostly filled with electrons. The size and intensity of this outer belt can change dramatically, swelling or shrinking depending on solar activity, like solar flares or coronal mass ejections from the sun. Think of it as a cosmic weather system, constantly in flux. Now, discovering these belts was one thing, but figuring out what to do about them was another. For space exploration, the Van Allen belts are a huge roadblock. The radiation within them is a serious threat to both astronauts and spacecraft. For humans, prolonged exposure to this level of radiation can cause severe health problems, increasing the risk of cancer and cellular damage. It's like standing next to a leaking nuclear reactor. That's why missions with astronauts on board have to be planned very carefully. Take the Apollo missions to the moon, for example. To get to the moon, the astronauts had to fly right through the Van Allen belts. How did they survive? NASA's solution was brilliant in its simplicity. Speed. They plotted a trajectory that took the Apollo spacecraft through the thinnest parts of the belts at very high velocity. The astronauts were only inside the most intense radiation zones for a short period less than an hour. The metal hull of the command module also provided some shielding. In the end, the total radiation dose the Apollo astronauts received was roughly equivalent to a few medical X-rays, well within safe limits. But it was a calculated risk, and it highlights just how dangerous these belts are. It's not just humans who are at risk. Our precious, multi-billion-dollar satellites are also in danger. The high-energy particles in the belts can wreak havoc on electronics. They can cause what's known as a single-event upset, where a particle hits a microchip and flips a bit from a 0 to a 1, causing a software glitch or a system shutdown. In more severe cases, the radiation can degrade solar panels, reducing their ability to generate power, or even permanently fry sensitive electronic components, effectively killing the satellite. Engineers have developed several strategies to protect spacecraft. One method is called radiation hardening. This involves designing electronics with special materials and circuit layouts that are more resistant to radiation damage. It's effective, but it's also very expensive and adds weight to the satellite. Another approach is shielding. Satellites are often wrapped in layers of aluminum or other dense materials to block some of the incoming particles. However, you can't just add infinite layers of shielding, because every extra kilogram launched into space costs a fortune. So, it's a constant trade-off between protection, weight, and cost. Mission planners also use clever orbital mechanics. Many satellites, especially those in low Earth orbit, like the International Space Station, fly below the inner radiation belt. The ISS orbits at an altitude of about 400 kilometers, safely underneath the most intense radiation. However, there's a catch. The South Atlantic Anomaly. This is a region over the South Atlantic Ocean where Earth's magnetic field is weaker and dips closer to the surface. As a result, the inner Van Allen belt also dips down, and the ISS passes through this anomaly several times a day. During these passes, astronauts often report seeing strange flashes of light, even with their eyes closed. These are cosmic rays hitting their optic nerves. To protect sensitive equipment, non-essential systems on the ISS are often powered down during transits through the anomaly. Satellites in geostationary orbit, which are crucial for our communications and weather forecasting, have a different problem. They sit at about 36,000 kilometers altitude, right in the heart of the dynamic and unpredictable outer radiation belt. These satellites need to be heavily shielded and radiation hardened to survive for their 15-year-plus lifespans. They are constantly being bombarded by electrons, especially during solar storms, when the outer belt can become thousands of times more intense in just a few hours. Despite the challenges, the Van Allen belts aren't all bad news. In a way, they act as a part of Earth's defense system. By trapping dangerous solar particles, they help shield the surface of our planet from the full force of solar radiation. Without the magnetosphere and the belts, our atmosphere would likely have been stripped away by the solar wind billions of years ago, much like what happened to Mars. So, these hazardous zones are also part of the reason life can exist on Earth. Today, scientists continue to study the belts with missions like NASA's Van Allen probes, which operated from 2012 to 2019. These twin spacecraft flew right through the belts, giving us an unprecedented look at how they work. The probes revealed the belts are far more complex and bizarre than we ever imagined, with particles being accelerated to near light speed by mysterious plasma waves. Understanding this space weather is becoming increasingly vital. Our modern world depends on satellites for GPS navigation, global communication, financial transactions, and national security. A severe solar storm could energize the belts to a point where they could wipe out hundreds of satellites, causing a technological blackout that would affect everyone on Earth. So, the next time you use your phone's GPS or watch a satellite weather report, remember the invisible challenge that had to be overcome to make it possible. The Van Allen belts are a perfect example of how space is both a frontier of incredible discovery and a harsh, unforgiving environment. They were one of the first great mysteries of the space age, and even today, they continue to surprise us, reminding us that there's still so much to learn about our own cosmic backyard. Thanks for joining me on this deep dive into the Van Allen belts. If you enjoyed this journey into space, don't forget to hit that like button, subscribe for more adventures, and let me know in the comments what other cosmic mysteries you'd like to explore next. See you in the next video.